Good morning everyone. We are the students of CSEC class. We are going to talk about the importance of vector calculus in artificial intelligence. Artificial intelligence or AI is a technology which makes or like it takes decisions like humans or things like humans. So it like for example, face recognition in mobile phones or talking assistants like Siri or automated cars. All these are AI things. Like so, AI works mainly based on mathematics. So vector calculus, branch of mathematics, is very useful in artificial intelligence. So now let me tell you why AI needs vector calculus. In AI, data is stored in form of vectors. That is group of numbers. For example, if we take an image is converted into thousands of numbers. Or if we take a voice recording or some recording, it is also converted or stored into thousands, like in the form of vectors. So, for to make AI think clearly or think accurately, we need to adjust many values and reduce errors and improve precision or improve accuracy. For this, we include the concept of gradient in vector calculus. Vector calculus, in gradient helps to reduce errors and adjust values and improves precision and accuracy.
So as you was telling, so vector calculus is more important when we talk about artificial intelligence. Artificial intelligence is nothing but it's mathematics. For example, let us assume we have an image. Each and every image is considered as a vector. Each and every image is considered as a vector. Okay. Suppose if you have a data set, it has n number of images into it. Right? If you take a data set, for example, we are talking about image processing, for example, using artificial intelligence, maybe using neural networks, deep learning, whatever. So, if you take a data set, you have thousands of pictures into it. Maybe if I am talking about image processing, so each picture will be termed as a vector. Each picture will be termed as a vector, and you know, for example, if I say this is the data set, maybe I have n number of images in this. This entire block, this entire structure is called vector space. It is called vector space. So in the vector space, we have n number of vectors. So maybe I may be told to do some work into it. Maybe I want to do some kind of clarity enhancement. Maybe so maybe I want to change the clarity, maybe quality of the pictures. So maybe I want to work pixel wise. I want to work with pixel wise. So maybe if I take one image, in this image I will have multiple pixels here. If you take one image, in each image it will be comprising multiple pixels. Each pixel is called your scalar. Each pixel is scalar because pixel carries a number. Pixel carries a number. So each and every pixel will be termed as scalar. So scalars put together along with the properties of the vector quantity we combine to form the entire vector space. So you can see from the fundamental basic pixel level to the broad end, everything is connected with mathematics. So vector calculus is a very fundamental tool and directly applied implying tool for artificial intelligence. Okay, proceed.
I am going to talk about the role of gradient in artificial intelligence. First of all, we need to know what is a gradient. Gradient will help to find out the direction in which a function is suddenly increases or decreases. So this gradient will help us to reduce the error and make them in a accurate form. So next, in machine learning, we will use a method called gradient descent. So this will reduce the error and make them in a perfect form. So for example, if we are considering a model, so there is some wrong prediction in this. So for this case, we use gradient and there is a specific formula. function. So we are using a gradient. So for the formula of gradient, we are taking the partial derivatives for each variable. So this method will reduce the error and make them to a perfect.
So in the partial derivative concept, you can understand the rate of change. So rate of change that happens along x1, along x2, along x3. So we can understand how far the changes is. And again, when she was telling that minimizing the error. For example, let us assume we have a set of y values. So maybe x1, x2, etc. to xn. So these are original values. Let us assume original values. So you are doing AI technology and you are getting some output. Maybe I call it as y1. So y1 equal to maybe so 1 1 2x 2 2 maybe some sort of results. So here now what is error? So this is the predicted values. This is actual values. Now the difference between the actual value and the predicted value is the error, because somehow it has to match with the reality. Am I right? So if the deviation is more, your outcome is more deviated with what actually it has to be, then that is called the error. In order to minimize the error, we can use the concept of vector idea. Okay, we can use the concept of vector idea. In the vector idea, in particular, the concept called gradient descent. Okay, this idea is used in order to optimize the error in algorithms. This is actually an algorithm. Okay, thank you.